Greetings everybody and welcome back to another video. I'm back after like 11 months or something. I've been summoned once again because, well, new methods exam just dropped. I just got my hands on a copy of this exam that the students finished like 15 minutes ago. And yeah, we're going to go through it live. I haven't seen any of the questions, so I guess you'll see my first reaction to this exam. So hopefully it's not too bad. I'm pretty washed up at methods as well, I think, because all the maths I do now is like nonsense. So I feel like I'm going to forget how to add numbers together or something. But yeah, let's jump straight into it. So first of all, we got a derivative question, your standard derivatives. This is just product rule with a bit of chain rule. So dy dx, let's differentiate e to the x, which is e to the x. We keep the cosine of 3x, and then you add. You keep the e to the x, but then you differentiate cosine of 3x. So that's actually going to be, we got a negative because cosine turns to negative sign. Then we have 3 e to the x sine of 3x. Hopefully I get that right, otherwise that's a bit embarrassing. F of x equals this log, finds f prime of 3. So f prime of x, how do you differentiate a log? You do 1 over the inside, so x cubed minus 3x plus 2, and then you multiply by the derivative of the inside, so that's 3x and then minus 3, I believe, and then let's plug in 3, so f prime of 3 is 1 over, we have 27 minus 9 plus 2, I think that's right, 27 minus 9 plus 2, yep, and then we have, that's going to be 9 and then minus 3. Hopefully my arithmetic is correct. So what's 27 minus 9? That's something like 18. Then you have plus 2, so that's 20. And then you have 9 minus 3, which is 6. So that's going to be, what's that? 3 on 10, I think. We'll go 3 on 10. I'm going to reduce the size of this pen slightly. It's a bit too thick. Okay, so what's the next question? Question 2 considers simultaneous linear equations. Determine value of k for which it has no real solutions. I think we can do it using matrices, or maybe I'll just use gradients. So no real solutions means, what does that mean? No real solutions means you're parallel, so same gradients, I guess. So let's try to find the gradients of these. So to do that, let's rearrange everything. So we have 2y equals k plus 4. Minus 3k times x. So y is equal to, that's going to be 3 on 2 times k times x. And then we have minus k on 2 and then minus 2. That looks right to me. So this is equation 1 here. And then equation 2, how can we rearrange this? So we have k times y is equal to negative k, and then minus k minus 4 times x. Okay, so that means y is equal to, we have a minus 1, and then a minus k on 4 over k times x. So this is equation 2. So let's take a look at let's make the gradients equal. So write m1 equals m2. So if m1 is equal to m2, then we have, well, what are the gradients? The gradients are over here. Oh, that's not even the right equation. Let's get rid of that. So the gradients, where am I even looking? So the gradients are over here. That's gradients 2, and gradients 1 is this guy here. So if we solve this, we want 3 on 2 times k is equal to negative k on 4 over k. Okay, so let's continue. So this means that's 3 on 2 times k squared is equal to negative k and then plus 4. Okay. So let's multiply everything by 2. So we have 3k squared is equal to minus 2k and then plus 8. And we'll rearrange now. So we have 3k squared plus 2k minus 8 equals 0. This is a 3-marker question, so maybe there's a easy way to do this, I don't know. So this implies, well, let's try to factor this now. So we have, well, there's a 3k and there's a k. I want an 8 there, so we have 2 and 4 probably. So let's think here. 4 would probably go here, and then we probably have 2 here. Does that make sense? I think it does. So we have, let's figure out the signs as well. So I want a plus 2k here, which means I want a negative going here and a plus going here, because this will give me minus 4 and then plus 6k, right? Which is 2. So this is equal to 0. So this tells us that k is equal to 4 on 3, or k is equal to minus 2. And then now let's see which one gives us different lines. So if k is equal to minus 2, then we get, what equations do we get? We get a minus 6x and then minus 2y is equal to 2. And then we have minus 6x minus 2y is equal to, yeah, k was minus 2, right? So this is the same thing. So we don't want k equals 2. K equals minus 2. I should get a red pen here. So this is bad. So let's make sure that k equals 4 and 3 doesn't give us anything. So what happens when k is 4 and 3? When k is 4 and 3, we get 4x minus 2y equals 4 and 3 plus 4, which is something. And then we have 4 and 3 minus 4. I don't know if I should check this at all. 4 and 3 minus 4. What's 4 and 3 minus 4? That's 4 and 3 minus 12 on 3. So that's minus 8 on 3. So minus 8 on... I feel like we're not going to get that's the same equation, it seems like. But we'll check it. So minus 8 on 3x, then plus 4 on 3... Was it 4 on 3? Yeah, 4 on 3y is equal to minus 4 and 3. So we get minus 8x plus 4y equals minus 4. But dividing everything through by 4, we get, what's that going to be? 1. And then we have minus 1 here, and then this is like 2. So I don't think we get the same equation. Because this is, if you divide this one by 2, well, there's no shot, whatever that number is, divided by 2 will give you 1. So we'll go with k equals 4 and 3. I felt like I spent way too long on that question. I'm pretty sure there's an easier way to do this using matrices and computing the determinant, but I kind of forgot how to do that. So I'll just stick with that method. Okay, we have a truncus on the axis sketched a graph of y equals g of x. Okay, so we have, this is defined over all real numbers excluding 3 or negative 3. So we have an asymptote at negative 3. So let's put that in. So here's our asymptote. This is x equals minus 3. And then we have an asymptote at minus 2. So let's put that in. Here's minus 2. Y equals minus 2. And then we want to find intercepts as well. So intercepts. 1 over x plus 3 squared minus 2 equals 0. So that's solving this guy equals to 2. So that means we have a half equals x plus 3 squared. So that means 1 on square root of 2 is equal to x plus 3 with a plus or minus. So x equals, that's going to be minus 3 plus or minus 1 on root 2. Or let's write this as root 2 over 2 to make the examiners happy. So root 2 on 2, well, root 2 is approximately 1.4, so root 2 on 2 is approximately 0.7. So that means you're going to get intercepts probably around over here and over here. Let's compute the y-intercept as well. So if you plug in x equals 0, then, well, this is g rather, so g of 0 is equal to 1 on 9 and then minus 2. So this is 1 on 9 minus 18 on 9, so that's negative 17 on 9. Okay, so let's see. 9th minus 2. That's going to be over here. So we have minus 17. So this point, let's label with the coordinates. So this is 0 minus 17 on 9. And then we have minus 3 plus square root of 2 on 2. And then minus 3 minus square root of 2 over 2, comma 0. So that should be it there. And then we have a truncus kind of shape going through, like so. Lovely. So that should be it there. We have our domain correct and everything. Okay, let's put little arrows here as well. Okay, part B, determine the area of the region bounded by the line x equals minus 2. The x-axis, the y-axis, and the graph of y equals g of x. Wait, I'm confused. Determine the area of the region bounded by the line x equals minus 2. So this is x equals minus 2 here. The x-axis and the graph of g of x. So this little triangle in there. Okay. I don't think that's too bad to compute. So we just need to do the integral from, well, that's going to be minus 3. Oh, this is going to be so much arithmetic. I know it already. So minus 3 plus root 2, all the way up to minus 2. Of, we have 1 over x plus 3 squared. And then we have a minus 2 dx. Oh boy. Okay, so let's try this. So this is going to give us, is there an easy way to compute this? I don't think so. I think we'll just have to brute force this computation. So that's anti-diff this. So this is going to give us a minus 1 on x plus 3. And then we have, so let's split this as well. So this is minus 3 plus root 2 on 2, and then minus 2. And then we have minus 2, and then this is going to be x evaluated from minus 3 plus root 2 on 2 all the way up to minus 2. So let's bring this negative out as well. So we have a minus over here. Okay, so let's compute. So this is equal to minus, we have a 1 on, so negative 2 plus 3 is 1, so this is just 1 here, and then minus 1 over, this is just going to be, well, root 2 on 2, right, because the negative 3 and 3 will cancel. Okay, so that's not too bad, and then we have minus 2, and then we plug in negative 2, and then we subtract off whatever we get when we plug in this guy. So plus root 2 on 2. Okay, so this is equal to minus, we have a 1 minus square root of 2, because this guy is just 1 over root 2. And then we have a minus 2. Let's factor out the negatives as well. So this is going to give us plus 2, and then 2, well actually, let's just leave it as it is. Let's do one step at a time. So minus 2, and then we have, that's going to be, that's minus 2 plus 3, which is 1. And then we have minus root 2 on 2. Okay, so let's simplify further. So this is going to give us a root 2 minus 1, and then minus 2, and then plus root 2. So what is this going to give us overall? This is going to give us 2 root 2, and then minus 3. And root 2 is approximately 1.4. So 2 root 2 is like 2.8. So 2.8 minus 3, that's going to be a negative number, which is consistent with what we have here, and it's also a small negative number. It's like 0.2. We've got a small region here, and it's below the x-axis. I'm fairly confident we did our computations correctly. So the area is just going to be 3 minus 2 root 2, because you're just going to multiply by a negative. So we'll take this as our answer. All right, question 4, let x be binomial with this distribution, find the standard deviation of x. What was the standard deviation formula again? It was something like the square root of np 1 minus p. So this is equal to the square root of n times p times 1 minus p, which is 1 over 10. So this is equal to, we have 2 times 3 over 10. Right, just take the square root of each part separately. So this is equal to 3 on 5. Find the probability x is less than 2. Is there a good way to do this? Probably just brute force. So probability, this is equal to probability x equals 0, and then plus probability x equals 1. So probability x equals 0 goes something like, well, n is 4, so you do 4 choose 0, and then you do probability of success, which is 9/10 raised to the 0, then 1/10 raised to the 4. And then we have plus probability of x equals 1, something like 4 choose 1, and then you do success probability, so that's going to be 9 on 10, raised to the 1, and then 1 on 10 raised to 3. Okay, so 4 choose 0, that's just 1. And then we have 1 over 10 to the 4. And then we have plus 4 choose 1 is 4. And then we have, that's going to be 9 divided by 10 to the 4. So combining everything together, we get, that's going to be 37 divided by 10 to the 4. Because 4 times 9 is 36, I think. So plus 1 is 37. Maybe we should write this out. So 37 over, well, 10 squared is 100. 10 cubed is 1,000. So 10 to 4 is 10,000. So we'll take this as the answer. Doesn't make sense though. So the distribution will be, well, if this is 0 to 4, 9/10, so the mean would be like up over here. So you get this sort of shape. So if you're doing x less than 2, then you're only doing 0 and 1. So the probability down here is really small, which is consistent with our answer. Okay, next question, question 5. This function models population of a town. Use the model H to predict the population of the town after 4 years. So this is after t years. So I guess if we want after 4 years, then we just do H of 4. Right? Yeah, it's 3,000 and then divided by 5. So that's going to be equal to, 30 divided by 5 is 6, I think, so that's going to be 600. A new function h1 models a population where h1 of 0 equals h0, but h1 decreases at half the rate of h at any point in time. State a sequence of 2 transformations that maps h onto this new model h1. So this is a decreasing function, but h1 decreases at half the rate of h at any point in time. So that means that the derivatives, so let's write it out like this. The dh1 on dt is equal to a half dh on dt. But this just means that h1 is, if you integrate both sides, h1 plus some constant, let's say c, is equal to a half h of t actually. So h1 of t. Right, so if you plug in t equals 0, you should get the same thing. So this implies that c equals 0. So let's write, since h1 of 0 equals h of 0. So if you plug in 0, you should get the same thing. So this means that c equals 0. It should make sense. Actually, maybe not. No, this is wrong. C is not equal to 0. Right, because there's some... h of 0 is not 0. So if you plug in h of 0, then you get h... So let's write this out properly. Then h1 of 0 but h1 of 0 is h of 0, right? So this is really h of 0 plus c equals a half h of 0. But what is h of 0? H of 0 is 3000. So 3000 plus c equals a half of 3000, which is 1500. So this tells you c equals 1500. Okay. Right. So we know that's h1 of t plus 1500, which we move to the other side, is equal to a half times h of t, and then minus 1500. Right. Does this make sense so far? I think it does. Okay. So the sequence of transformations are 1, dilation by factor of 1/2 from the x-axis, and then 2, dilation, not a dilation, sorry, translation by, that's going to be 1500 units in the negative y direction. So this should make sense because, well, h of t looks something like this. If you want to reduce the rate by half, then you can, well, dilate by a factor of half from the x-axis, which reduces the rates by half. But then you got to move it up again so the start points match up. Sorry, that was a completely incorrect explanation. So this is h of t here, and h1 you multiply by, wait, I'm so confused. h1 decreases at half the rate of h. Oh yeah, so h2 should, sorry, h1 should actually be double, right? It should be twice. Or maybe I'm doing something wrong here. So h1 decreases at half the rate, so the rate should actually be a half. So if the rate is a half, you multiply it by 2. I think this is right here. Maybe I'll go back later and I'll think about it, but we'll just take this for now. So in their town, 100 people were randomly selected and surveyed, with 60 people indicating that they were unhappy with the roads. Okay, so determine an approximate 95% confidence interval for the proportion of people in the town who are unhappy with the roads. Use equals 2 for this confidence interval. Okay, so the confidence interval formula goes something like p hat plus or minus z times the standard deviation of p hat. So p hat, so 60 people said they were unhappy with the roads. So the p hat is going to be, let's write it here, p hat is going to be 60 on 100, or 3 on 5. So this is 3 on 5, plus or minus, we have z equals 2. And then the standard deviation, so how do you calculate standard deviation of p hats? It's the square roots of p hats, 1 minus p hats, divided by n. So this is going to be the square root of 3 on 5, and then times 2 on 5, divided by n, which is 100. So this is going to give us, that's going to be something over 10. We have 2 5s, so a 5 remains. And then we have the square root of 6. Okay. So this gives us square root of 6 over 50. So we have the square root of 6 over 50. So the confidence interval is going to look like, well, let's simplify this further. This is 3/5 plus or minus. We have square root of 6 over 25. So let's rewrite 3 on 5 as, what's 3 times? So that's 15 over 25. So we have 15 plus square root of 6, or maybe, just to make it simpler, let's actually just keep it as 3 on 5. So we have 3 on 5 plus or minus that. So the confidence interval is 3 on 5 minus square root of 6 over 25, and then 3 on 5 plus the square root of 6 over 25. Alright, so we'll take this as the answer. A new sample of n people results in the same sample proportion. Find the smallest value of n to achieve a standard deviation of root 2 on 50 for the same proportion. Right, so we have the old standard deviation was sigma p hat. What was this? This was root 6 on 50. So square root of 6 on 50. And then we want sigma p hat tilde, the new one, to be equal to square root of 2 on 50. Okay, so let's think. We have sigma p hat. This was equal to, or let's do it for the tilde, so the new one. This is the square root of p hats 1 minus p hats divided by n. And well, this new guy over here, this is just 1 on root 3 times the old one. Okay, so we have 1 on root 3 times the old one. So this is for a new n over here, so let's call it n tilde. So this means we want this to be equal to 1 on root 3 times the old one. So this is the square root, the same p hats, 1 minus p, and then divided by the old n. So the question is, what should this new n be? Well, let's rewrite this second part. This is the square root of p hat 1 minus p hat divided by, this is going to be 3n here. So if you just match things up, n tilde should be equal to 3n. So that's the smallest one there. N was 100, so this is actually going to be 300. So let's make sure this makes sense in our heads actually. We want to decrease the standard deviation. So to decrease the standard deviation, which is the uncertainty, you should actually increase the sample size, which is what we did. So it should be 300. All right. So question 6. This is a log equation. Let's think here. So we have, let's combine things together. So we have, well, first of all, we want to combine the logs, so let's get rid of that 2. So this is log base 3, and then we have an x minus 4, and this is raised to the 2. And then we have plus log of x, log base 3 of x, and this is equal to 2. So, well, this is equal to, well, let's add the logs together. So this is log it, and then we have, let's expand things out as well. So this is really x, and then x squared minus 8x, and then plus 16. And this is equal to 2. So if we rearrange things, then we get, well, what does it mean for, what does log mean? It means 3 raised to 2 equals to the thing. So this means 9. Let's write this out properly. 3 raised to 2, which is 9, is equal to x cubed minus, well, let's keep it in factorized form. Maybe that's easier. So this is x, and then x squared minus 8x plus 16. Actually, I should have expanded. So this is x cubed, and then minus 8x squared, and then plus 16x. I think. So let's rearrange things. So we get x cubed minus 8x squared plus 16x minus 9 equals 0. Is there a nice way to factor this? Let's make sure I expanded things out properly. So I put the 2 up. So this expands to x squared minus 8x plus 16, and then we have an extra x coming in. Yes, this looks good. So we have 9 equals that, because 3 raised to the 2 is the inside. Okay. So maybe we just have to try to factor this somehow. So let's try to factor it. What happens if we plug in, let's do factors of 9. So what happens if we plug in 1? We get 1 minus 8. And then we have plus 16 minus 9. This seems like it works because 1 minus 8 is minus 7. And then plus 16. So you can plug 1 in. So by null factor law, whatever it's called, x minus 1 is a factor. So let's try to do long division. So we have x cubed minus 8x squared plus 16x and then minus 9. We divide this by x minus 1. So this gives us an x squared. Multiplying down, we get x cubed minus x squared. Subtracting. And then we have minus 8 and then plus 1. So that's minus 7 x squared. And then we have plus 16x. So let's repeat. So we divide. So this gives us a minus 7x. Bring it down. We get minus 7x squared and then plus 7x. Subtracting everything, we get 16 minus 7, which is 9x, and then minus 9. And then dividing once more, we have a plus 9 here. Right, so 9, and then we get a 9x minus 9, which when you subtract, you get 0. Okay, so this polynomial here, let's bring this down. This polynomial, x cubed minus 8x and so on, you can factor it as x minus 1 times this quadratic, which let's try to factor it further. So factors of 9, can we factor that? So it's 3, I don't think so. 3, 3, so you can't get a 7. Does this quadratic have roots is the next question. So let's try the discriminants. So we have b squared minus 4ac. Sorry, b squared minus 4ac. So b squared is 49, and then minus 4 times a times c. So this gives us solutions, right? It's because 4 times 9 is 36. You get a positive determinants, not determinant, discriminants. So I don't know how to factor this. Maybe let's use quadratic formula. So that's going to be something like, sort of over here, 7 plus or minus the square root. So that's b minus b plus or minus b squared, which is 49 minus 4, times a times c, which is 9, over 2a, which is 2. So this is 7 plus or minus the square root of 49, and then minus 36 over 2, and this is 7 plus or minus. What's 49 minus 36? 49 minus 36, that's something like, is that 13? Square root of 13. Now I feel like I'm doing this wrong. So we have, 7 plus or minus root 13 on 2. So I guess we'll put those in as solution. So let's write this out properly. So we get x equals 1, x equals 7 plus root 13 on 2, or x equals 7 minus root 13 on 2. So these are the 3 solutions. Now we're just going to make sure that all of them work. So x minus, we want to make sure that if you plug these in, you get some x is positive, and also x minus 4 is positive as well. So let's see here. So x minus 1 wouldn't work because when you plug it into x minus 4, you get minus 3, so that's bad. 7 minus root 13 also doesn't look great, because root 13, that's something like, well, root 13 is a bit more than root 9, and root 9 is 3. So this is a bit more than 7 minus 3, right, over 2. And that's like 2. So if you subtract 4 from it, that's definitely bad. Now this is promising because it's greater than 0. So let's make sure when we take 7 plus root 13 over 2, and then we subtract 4 from it, it's still positive. So this is equal to 7 plus root 13 over 2, and then this is minus 8. And this is going to give us, well, that's going to be root 13 minus 1 over 2, which is positive because root 13 is greater than 1. So the solution, there's only one solution it seems like. It's 7 plus the square root of 13 divided by 2. So we'll take this as our answer. Maybe I should write a bit more down here, but yeah, I'm too lazy. Okay, how many more questions do we have? I've spent I think I started at 11:35 roughly, so I've spent 40 minutes on this, so we have another 20 minutes. Question 7, part of the graph of f is shown. Okay, use the trapezium rule with a step size of pi on 3 to determine an approximation of the total area. Trapezium rule. So we want something like this here. So something like that, and then this goes all the way down. Right, so now I kind of forget how trapezium rule works. So it's something like we have you do, what was the rule for it? You do a half and then times step size, which is pi on 3, and then you count the endpoints once here, and then you count the things in the middle twice because they appear in two trapeziums. So we have 0, and then we have plus 2 times 1, because that's the y value, and then plus 2 times, well, now we have to do, wait, I don't think that's 1 there. No, that's not 1. I'm tripping. So that's not 1. Let's plug it in properly. Why can I not erase this? So f of pi on 3 is equal to pi on 3 times the sine of pi on 3. What's sine of pi on 3? That's like root 3 over 2. So this is equal to pi times, pi root 3 over 6. So this is pi root 3 over 6 here. Pi root 3 over 6. And then we have plus 2. Now we have to plug 2 pi on 3 in. So if we do that, f of 2 pi on 3, well, this is equal to 2 pi on 3, and then sine of 2 pi on 3, which is also root 3 on 2. So here, some things cancel, so you get pi on, or pi root 3, and then divided by 3. So this is plus 2 pi root 3 divided by 3. And then you have, if you plug pi in, you just get 0, so this is just 0 once again. So let's compute. So the half and the 2's in there will cancel, so this is pi on 3. And then we have pi on root 3 over 3. And then plus pi 2 root, that's right, this has 2 pi, root 3 over 3. So this is equal to pi on 3. And then we have, well, pi on 3, so that's going to be 3 pi root 3 on 3. So that's going to be pi root 3. Right, because the 3's cancel. So this is going to be pi squared root 3 on 3. Finds f prime of x. Why are you asking me to do a derivative in question 7? Come on now. F prime of x is equal to, we have sine of x, and then plus. So I diff the first, I keep the seconds, then I keep the first, diff the second, so x cosine of x, something like that. Determine the range of f prime over this interval. What? So pi on 2 to 2, so let's take a look on this graph here. Pi on 2, so we're going to go from here all the way up to 2 pi on 3. So 2 pi on 3. That looks like a turning point, maybe. I don't know. It's probably not, actually. What is this question trying to get me to do? Determine the range of f prime. Well, f prime looks like it's increasing on that interval. So let's see. F prime is this thing, and I want to find the range of it. So let's plug in the endpoints. So f prime of pi on 2 is equal to, we have sine of pi on 2, which is 1. And then plus pi on 2 times cosine of pi on 2, which is 0. So, yep, it's just 1. And then f prime of 2 pi on 3. This is, so if you plug 2 pi and 3 in, sine of 2 pi and 3 is going to be root 3 on 2. And then plus x. So x is going to be 2 pi and 3. And then cosine, right? Cosine of 2 pi and 3. What's cosine of 2 pi and 3? That's negative a half. So this is equal to root 3 on 2, and then minus pi on 3. Right. So determine the range of f prime. So we're just going to make sure f prime doesn't have any turning points on the interval. So I should really calculate f double prime to see. So can we calculate f double prime without too much problems? So I'll just do it over here. So f double prime of x is equal to, that's cosine of x, and then plus, I have to differentiate this now, so I keep the first, I differentiate the seconds, that's a minus x sine of x, and then plus, now I forget how to differentiate things. So we keep the first, differentiate the seconds. Then we differentiate the seconds and keep the first. So cosine of x. And if I try to solve that, that's probably impossible to do. So I'm just going to look at this and say, well, the turning points looks like it's a 0. What am I even saying? The turning point is over here roughly. So does this make sense? Maybe. Let's just take that as the answer. I'll probably be wrong though. I don't know. So this is going to be root 3 on 2, minus pi on 3, and then comma 1. Hence verify that f of x has stationary points. Well, you just want to show that f prime could be equal to 0, right? So let's take a look at root 3 on 2 minus pi on 3. The question is that less than 0? Maybe. Now I need to somehow do approximations. How do you show it's less than 0? So this is, maybe the stationary point is occurring slightly before. I'm not too sure actually. How do we show that's less than 0? Well, if this is less than 0, let's see if we can get some kinds of consistent arguments. So let's multiply everything by 6. So this is going to be equal to 3 root 3, and then minus 2 pi. I don't know if I can get any good bounds here. So I know if we bring 2 pi over, this is less than 2 pi. Can we get any good bounds in this? I don't know. Let's leave it for now, because I don't know how to get a bound on that. On the set of axes below, sketch the graph of y equals f prime on this domain. So f was the original graph, and we want to sketch f prime on minus pi to pi. Labeling the endpoints with the coordinates, you may use the fact that the graph of y equals f prime has a local minimum at approximately minus 1.1 and minus 1.4. So what are we supposed to do? On the set of axes below, sketch the graph of f prime. So this is f of x here, and we want to sketch f prime. You may use the fact that the graph of f prime has a local minimum at approximately minus 1.1, so that's over here, and then minus 1.4. And the local maximum on the other side, so right over here. Okay. So we want to go from minus pi to pi. So how can we do this? Well, it's definitely going to pass through 0. And we have some turning points over here, roughly. Right, so I can get a rough shape for this already, because over here we're going negative, so we're just going to keep going down. But maybe I should calculate what f prime is at minus pi and pi. So f prime at pi, what's f prime of pi? That's going to be sine of pi, which is 0. And then we have, this is going to be minus pi there. Right, because we have pi, and then cosine of pi, which is negative 1. So this is minus pi. So minus pi is going to go over here somewhere. Right. Sorry, this is f of pi. So f of pi would go down here, but f of minus pi would have pi instead by symmetry. So we'll have a graph that looks something like this. Sketch the graph of f prime on the domain minus pi to pi. So I think you should include endpoints here, right? Because, oh wait, the graph of f only goes from minus pi to pi. So because our original function doesn't include, or the endpoints are minus pi to pi, we should have open endpoints here, I believe. So open, and then we have a line going through something like this. Okay, do I need to label anything? Labeling the endpoints with their coordinates. So minus pi comma pi, and then over here we have pi comma minus pi. Maybe I'll label these as well for good measure. So minus 1.1, minus 1.4. Then over here we have 1.1 comma 1.4. Okay, that's the final page, I guess. So question 8, we have this cube roots where k is not 0 and m is a real number. Let the point P be the y-intercept of the graph. Find the coordinates of P in terms of k and m. So this is y-intercept, so let's plug in 0. So g of 0 is equal to the cube root of minus k and then plus m. Find the gradient of g at p. So, oh wait, this is find the coordinates of p. So I should write 0 comma cube root of minus k and then plus m. Find the gradients of g at p in terms of k. G prime of x is equal to, well, that's going to be the derivative. Let's rearrange this or rewrite it. So this is x minus k to the 1/3, and then we have plus m. This is 1/3 x minus k to the minus 2/3. The gradient at p, so this is g prime of 0, so this is going to be 1/3, and then minus k raised to the minus 2/3. Given that the graph of y equals g of x passes through the origin, express k in terms of m. So we know g of 0 equals 0. So that means cube roots of minus k is equal to minus m. So we want to express k in terms of m, so let's cube both sides. So k is equal to minus m but cubed, but this is minus m cubed, so k is equal to m cubed. Let q be the points. Let the point q be a difference point from P such that the gradient of G at points P and Q are equal. Given that the graph of G of X passes through the origin, find the coordinates of Q in terms of M. So, well, what's the gradients? The gradients was a third, so we know G prime, right, P was the y-intercept, so G prime of 0, we know that's what, a third, and then minus k to the minus 2/3. So we want everything in terms of m, so I guess we can write this as a third, and then minus m cubed to the minus 2/3. Let's see, so this we can rewrite this further, so this is 1/3. The negative can jump out because 2/3, I believe that feels like an, oh wait, if you have 2/3, that should be, because you have a 2 there, that should be an even function, so the negatives, you don't have the negative anymore. So this is actually just a third, and then we have m cubed raised to the minus 2/3. So this is 1/3, and then we have m raised to the minus 2. So that's the gradients there at 0, and now we want to equate this gradients to something. We want to equate it to g prime of x. Right? So so we have g prime of x is equal to 1/3, and then we have an x minus k to the minus 2/3. And we equate this to equal a third times m to the minus 2. So that means x minus k raised to the minus 2/3 is equal to m to the minus 2. So now I want to solve for x, so let's raise everything to the negative 3 on 2. So x minus k is equal to m to the minus 2 raised to the minus 3 on 2. But now I want to be careful because actually let's raise it to the power of 3 first, so that we still have x minus k to the minus 2 is equal to m to the minus 2. Sorry, is that right? Something dodgy is going on. So this is 2/3. So I want to raise it to the power of 3. So this is m to the minus 6. So if I take the square root on both sides, I get x minus k to the minus 1 is equal to plus or minus m to the minus 3. So that means x minus k is equal to plus or minus, that's going to be m cubed. So x is equal to k plus or minus m cubed. But k, we found, was something, k was m cubed. So actually this gives us x equals m cubed plus or minus m cubed. So if you take the negative, that gives you 0 back. So find the coordinates of q in terms of m. So we should take x equals 2m cubed. And if you plug 2m cubed into g, what do you get? Well, g of 2m cubed is equal to the square roots, or not the square root, the cube roots of 2m cubed minus k, but k was just m cubed, And then this is plus m. So this is cube root of 2m cubed. Sorry, that's just m cubed, cube root of m cubed, and then plus m. But that's 2m. So I'm going to take the answer to be 2m cubed, and then comma 2m. That was a very weird question. I don't know if I liked that question or not. It's a good test to see if you understand how to work with powers and whatnot. But yeah. So what questions haven't we done? We haven't done part 3 here. Hence verify. So determine the range of f prime. So you can plug in the endpoints, but I don't know if f prime has a turning point in there, so I don't know if it's enough to sub in just the endpoints, because it has a turning point in that interval. So in particular, if f double prime is equal to 0 on the interval, then we're kind of screwed. And then hence verify f of x has a stationary point. So I still don't know how to do this question. There's probably some smart bounds you could use that I can't think of right now. But I don't know. Hence verify that f of x has stationary points. I mean, you could mess around with a bunch of bounds here. Let's see. Square root of 3 is less than square root of 4, which is 2. So you know that 3 root 3 is less than... Oh, there we go. Wait, square root of 3 is less than square root of 4, so this is 6, right? So 3 times 2 is 6. But pi is greater than 3. Okay, so I think this makes sense here. Right? So let's observe a few things. So we have the following inequalities. We have pi is greater than 3, and root 3 is less than 2. Okay. So what did we want to show? We wanted to show, I think it was, yeah, we want to get a bound on 3 root 3. So this is less than 3 times 2, which is 6. And 6 is going to be less than 2 times 3, which is less than 2 pi. There we go. So this is actually the chain of inequalities that we want. So this implies that. So this tells us that 3 root 3 is less than 2 pi. So if you divide everything through by 6 now, you get root 3 on 2 is less than pi on 3. Right, so this implies that root 3 on 2 minus pi on 3 is less than 0. And maybe you should say something like continuity, since f prime is continuous. This is now stuff from real analysis by, what was it, the intermediate value theorem. So since f prime of pi on 2 is greater than 1, and f prime of 2 pi on 3 is less than 0, so f prime of x equals 0 for some x on this interval. So pi on 2 to 2 pi on 3. Okay, so now I'm a bit more happy because I can solve that. What other questions didn't I quite get? I think it was this one here. I was still unsure. So a new function h1. So new function h1 decreases at half the rate. So h of t would look something like this here. And what did we do? H1 was we dilates by a half, and then for some reason we subtracted 1500. That feels wrong. Let me think here. So this equation seems right. So we decrease by half the rate. So we have a plus c there. And then if we plug in h of 0, so h1 of 0 is equal to h of 0 plus c. Okay. So h of 0 is equal to 3000, right? So we get a 3000 over here, then we get a 1500. Oh, this is supposed to be minus here. That's where I went wrong. That's supposed to be a minus. So because c is minus, when you bring it over, that's a plus there. There we go. Okay, now I'm content. So this is actually in the positive y direction. Okay. And I think the rest I was happy with. This one was weird. Yeah. Question 5's an absolute mess though, because you do all this stuff and then like you go into confidence intervals, like, I don't know. This was fine, just standard binomial and then graphing stuff. Area seems fine. This I feel like I could have done faster, and then yeah, question 1's just question 1. So yeah, overall thoughts, I think it was some parts were fairly challenging, some parts were fairly routine though. So overall not a bad exam. I kind of tripped up in a few places because, as I said before, I'm completely washed up at this subject. Yeah, it's only this part I'm still not too sure about. I don't know. Maybe I forgot a few things, how to do a few things and methods. That would be useful to show this, but if I find out, then I'll put it in the comments or description or something. But yeah, that's all for this video, I guess, on the solutions. We'll see if I'm right or wrong on how many of these, but yeah, if you're watching this on the day of the exam, then yeah, good job for finishing. On to exam 2 next, so good luck for exam 2. Sleep well tonight. Don't stress too much, and yeah, good luck, and maybe I'll make another video tomorrow. I have an exam myself tomorrow as well. So my exams, I don't even know when my exam is. It's like in the afternoon, so roughly when your exams are. So maybe I'll make another solution video depending on how many brain cells I have left after doing my own exam. But yeah, until then, have a good day, and I'll see everyone in the next one. Bye bye.